Hi guys, I'm back with my lectures. I'm Mr. Joseph, your chemistry teacher, and today's lecture is in continuation of our previous lecture on lattice energy. In our previous class, we talked about lattice energy, and we discussed how you can use the Born-Haber cycle to calculate the lattice energy. So in today's lecture, we'll be looking at finding the lattice energy, how we can calculate the lattice energy, and also finding other quantities like the enthalpy change of atomization, enthalpy change of formation, enthalpy change of ionization, enthalpy change of electron affinity, and that's what we'll be looking at today in today's lecture. So in our previous class, we did justice to the Born-Haber cycle, which is a particular type of enthalpy cycle used to calculate what the lattice energy. With the help of the Born-Haber cycle, we can easily calculate the lattice energy, and we can also calculate other quantities such as enthalpy change of formation, enthalpy of electron affinity, enthalpy of atomization, ionization energy, and others. So that's what we're going to focus our attention on today. How we're going to calculate, how we can calculate what the lattice energy and other quantities. In our last class, we are meant to understand that the operation of the Born-Haber cycle is based on the principles of what the Hess's law, which states that what the total enthalpy change of a reaction is independent of the route that is taken, provided that the initial and the final conditions remains the same. So we are meant to understand that the indirect route is equal to direct route, and we came up with the formula for calculating lattice energy. Lattice energy would now be equal to enthalpy change of formation minus other quantities such as enthalpy change of atomization, enthalpy change of ionization energy, and enthalpy change of electron affinity. So we'll be using this formula. We're going to use this formula in full detail today. So please, I want us to listen attentively as we go into calculation so we can get the best out of it. So to calculate the lattice energy is enthalpy of formation minus the summation of enthalpy of atomization, ionization energy, and electron affinity. We can also calculate the enthalpy change of formation. It's just to make the quantity we want to calculate the subject of the formula, and it's as simple as ABC. We are going to solve few questions, and you'll be given tasks to work on, and also I will expect you to solve as many questions as possible for perfection. So this is an example of a typical examination question. Use your answer to II and the following data together with relevant data from the data book to calculate a value for the lattice energy for calcium chloride. Calcium chloride is an ionic compound, which is Cl2. So calcium consists of Ce2 plus and 2Cl minus. It's an ionic compound. An ionic compound consists of aggregate of oppositely charged ions. And during formation of ionic compound, it has to do with transfer of electron from the metal to the non-metals. The metals, they lose electron, become positively charged, while the non-metals accept electron, becomes negatively charged. So calcium loses 2 electrons to form Ce2 plus and gives its 2 electrons to 2 atoms of chlorine, because 1 atom of chlorine needs 1 electron. So quantities that has to do with chlorine here, we're going to multiply those quantities by 2. For example, we're going to multiply the enthalpy of atomization of chlorine by 2. We're going to multiply the enthalpy of first electron affinity of chlorine by by 2, because we have 2 moles of chloride ion. And we are given the standard enthalpy change of formation of calcium chloride. We are given the standard enthalpy change of atomization of calcium. We are given the electron affinity of chlorine atoms. So the values we don't have here is the enthalpy of atomization of chlorine, and the first and second ionization energy of calcium, of which we are going to check those ones from our data booklet. So from the data booklet here, let's check the to calculate the enthalpy of atomization of chlorine. Enthalpy of atomization of chlorine is equal to half times the bond enthalpy or bond energy multiplied by what? 2, because we have 2 moles of what? Chloride what? Ion here. So for us to get the enthalpy of atomization of chlorine, so we check from our data booklet the bond energy for what? Chlorine. That's the bond enthalpy of what? Chlorine. And from our data booklet, let's check our data booklet. From our data booklet, the bond enthalpy of chlorine here is what? The bond energy for chlorine is what? 242. Then we're going to check the first and second ionization energy of calcium. The first ionization energy of what? Calcium is what? 590. While the second ionization energy of calcium is what? 1150. So these are the values we need. So let's calculate the enthalpy of atomization of chlorine, which is half times what? 242, then times 2. So 2 year 1, 2 years 1, 2, 1. So multiply by 2, you still get what? 242. So the enthalpy of atomization of chlorine is equal to 242. So we now have all the values we need. So we'll now go over to calculation of what? The lattice what? The lattice energy. So to calculate the lattice energy, we already know the formula. Lattice energy is equal to what? Enthalpy of formation. So the lattice energy is equal to what? Enthalpy of what? Formation of calcium chloride minus the summation of what? Enthalpy of atomization of what? Of calcium, and what? Enthalpy of atomization of chlorine, then plus what? First ionization energy of calcium, and what? And second ionization energy of calcium, then plus first electron affinity of what? Chlorine. So we have to multiply the electron affinity of chlorine by 2. So it will be 2 times what? 2 times the first electron affinity of chlorine, which is 2 times the first electron affinity of what? Of chlorine. So going over to calculation, lattice energy now be equal to enthalpy of formation is what? Minus 796 minus bracket, enthalpy of atomization of calcium is 178. Atomization of chlorine is 242. First ionization energy of calcium is 590. Second ionization energy 1150. Then plus 2 bracket electron affinity of chlorine is minus 349. So we have to multiply it by what? By 2. So I'm to use my calculator now. So 178 plus 242 plus 590 plus 1150 is equal to plus 2 times minus 349. So this is what you get. Let me use my calculator to just do the total. Let me add everything. So here you have 1462. So the lattice energy, let me clean up this side so that I can. So the lattice energy now will be equal to what? Minus 796 minus 1462, which will now be equal to 2 minus 2,258, sorry, minus 2,258 kilojoule per watt per mole. So that is it, 2,258 watt kilojoule per mole. So you can see that is the lattice energy. Is an exothermic what? Exothermic process. You can see that the answer, it gives us what? A negative what? A negative value. So lattice energy is an exothermic what? Exothermic process. So as you can see, it's as simple as what? ABC. All you just have to do is just to apply the formula correctly, and also be conscious of signs while you're trying to add up, because it's very, very important. That is where most students, they make what? They make mistakes. So we're going to solve as many questions as possible. We're going to attempt another question also. So please, it's a very simple, solve as many questions as possible. So let's go to the next question. So this is another example of a typical examination question. Here you are asked to calculate a value for the enthalpy change of formation of magnesium oxide. So use the following data together with appropriate data from the data booklet to calculate a value for the enthalpy change of formation of magnesium oxide. So you can see that this one is a little bit different from the first one. The first one, we are asked to calculate what the lattice energy, but here we are asked to calculate the enthalpy change of what formation. You are given the lattice energy of magnesium oxide. You are given the enthalpy change of atomization of magnesium. You are given the electron affinity of oxygen atom. You are also given the second electron affinity of oxygen. So the values you are not given has to do with what the first and second ionization energy of magnesium, of which we are going to check that from our data booklet. Also, what the enthalpy change of atomization of oxygen, we are not given. We are going to check it from what average what bond energy, what energy value. So this is magnesium oxide, which is MgO. So it consists of what? Mg2 plus and what? O2 minus. It's an ionic compound. So are you getting it now? Magnesium oxide. So ionized by losing 2 electrons, and oxygen needs 2 electrons to complete its what? Octet state. So we'll have what? 1 mole of what? Magnesium ion, and 1 mole of what? The oxide what? Ion. So to get the enthalpy change of atomization will be equal to what? Half times what? The bond what? The bond energy of what? Of oxygen. Multiplied by 1, since we have 1 mole, or we'll just leave it that way. So we'll go to our data booklet to get the bond energy for what? For bond energy for oxygen. So we can get the enthalpy change of atomization for oxygen. So from our data booklet, the bond energy for oxygen is 496. So it will now be equal to 1 over 2 times what? Times 496. 496. So which is equal to what? If you divide by 2, you have what? 248. So that will be the bond enthalpy for what? For the enthalpy change of atomization for oxygen. So from our data booklet, let's look at the first and second ionization energy for magnesium. First and second ionization energy. So let me check my data booklet. The first ionization energy for magnesium is 736. So first ionization energy of magnesium is equal to 736. 736. Second ionization energy for magnesium. Second ionization energy for magnesium is 1,400 and what? 1,450. So now we now have all the values we need. The enthalpy change of atomization is 2 watts. It's already 248. So enthalpy change of atomization of oxygen is equal to what? 248. So the next thing, we have to calculate the enthalpy change of what? The enthalpy change of formation. So what we're going to do is we're going to make the enthalpy change of formation the subject of the formula. So therefore, enthalpy change of what? Formation will be equal to what? Lattice enthalpy lattice energy plus what? Summation of what? Enthalpy change of what? Atomization of magnesium and oxygen plus first ionization energy of magnesium plus second ionization energy magnesium plus what? First and second electron affinity of what? Of oxygen. Second electron affinity of what? Oxygen. So that is that. So we already have all the information before us, all the data before us. So enthalpy of formation now will be equal to the lattice enthalpy is minus 3791, then plus enthalpy of atomization of magnesium is 148. Enthalpy of atomization of oxygen is 248. First and energy of magnesium is 736. Plus second energy is 1450 plus first and second electron affinity. The first electron affinity of oxygen is minus 141. Then second electron affinity of oxygen is plus 798. So I'm to add up with my calculator. 148 plus 248 736 50 no plus 1450 plus then so here should be 141. So the enthalpy change of formation, let me erase this. Equal to minus 379 plus 3239, which should now be equal to and the 3791 so it will now be equal to what? Minus what? Minus 552. So enthalpy change of formation of what? Magnesium oxide will be equal to what? Minus 552 kilojoule per watt per mole. So as you can see, it's as simple as what? As ABC. So it just makes enthalpy change of formation the subject of what? The subject of the formula. You'll be given other values and also the values from the data booklet. So it's as simple as ABC. I'll be leaving a task with you, and please, I want you to attempt as many questions as possible. Please try and attempt that task, and in our next class, we might look at it and take the correction. And those of you, maybe you must have made one mistake or the other during calculation, you get to correct your what? You correct your mistake. So, I'm Mr. Joseph, your chemistry teacher. Please feel free to reach out to me if you encounter any difficulty in trying to attempt the tasks I'll be giving you now, or maybe you're attempting to solve questions on your own and you encounter any difficulty, just reach out to me. I'm always there for you, and I'm ready to help you in any way. So please feel free to reach out to me, and please subscribe to my YouTube channel. I'm Mr. Joseph, your chemistry teacher. Go to the comment section and give your feedback, and I'm always there for you. I'll be available for you. Once more, I'm Mr. Joseph, your chemistry teacher. So I'll be giving you the task now. So this is the question. Calcium chloride is an ionic solid. The values of some energy changes are given. They've given you all the data you need. So you're asked to define the lattice energy. Then use the data in table 1.1 to calculate the standard enthalpy change of formation of calcium chloride. So it may be helpful to draw an energy cycle. So show all your working. So it's as simple as ABC. Just attempt this task and we'll meet in our next class. Thank you for listening. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Please don't forget to subscribe. Don't forget to comment. Thank you very much. So this is an additional task to the previous one. Use your cycle, the following data and further data from the data booklet to calculate a value for the lattice energy of sodium or sodium oxide. So you have to solve this in combination with the other one I gave you. So I gave you two tasks to solve. So please try and attempt these questions. Get the data booklet and attempt these questions, and feel free to reach out to me for any difficulty. So I'll always be there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. Mr. Joe.